The derivative of e to the x is just e to the x. That's why it's so special. The derivative happens to be itself, and the derivative of a to the x is a to the x times the natural log of a. Now, that actually is the same rule up here. If I apply this rule, because a and e, well, the only difference is e we know is about 2.71828 dot dot dot, and a is any other number. If I did e to the x times the ln of e, well, the ln of e is equal to 1. That's why you don't see it in the rule above. So again, the derivative of e to the x is e to the x, and the derivative of a to the x, any other number, is a to the x times the natural log of a. To start, you could go ahead and be asked to find derivatives here. So let's find the derivative of f of x. F prime will be x to the fourth. Put the power in front, subtract 1 from the power. What's the derivative of 3e to the x? It's just 3e to the x. Follow me on this little side quest. Let me ask you a few questions. What is the derivative of x to the fourth? It would be 4x to the third. Awesome. What is the derivative of 5x to the fourth? Now, you probably said 20x to the third, which you are correct. But what you really did is you did 5 times 4x to the third to get that whole 20x to the third. I'm trying to show that constant times function, the derivative is a constant, and you just take the derivative of the function in front. That's really what's going on here. Meaning, if the derivative of e to the x is e to the x, then the derivative of 3 times e to the x is 3 times its derivative, e to the x. Moving on, g of x, the derivative, 5 to the x would be 5 to the x times the natural log of 5. I'm just using this rule right here. Again, 5 to the x, the derivative would be 5 to the x times the natural log of 5, plus 6x to the 2. Applications. Let's do some here. Find the normal line at x equals 0 to the following function. So we're finding, you'll see the answers would all be lines. So you would start by writing down point and slope. So the point is going to be, well, it's at x equals 0, so it'd be 0, comma, find f of 0, plug into the original. E to the 0 is 1, plus 0 plus 3 is 4. For the slope, you take the derivative. So the derivative of e to the x is e to the x. The derivative of 2x is 2. The derivative of 3 is 0. Plug in is 0. E to the 0 is 1, plus 2 is 3. And this is where I will see a mistake. I'll see students go, okay, so the slope is 3. The slope is 3 if it was asking for the tangent line. But this is asking for the normal line. So when you encounter this, write down point and normal slope so you don't forget along the way. Because especially if this ends up being multiple choice, I would anticipate there's going to be an answer that has the tangent line where the slope is 3 and the normal line, which is negative 1/3, because normal means perpendicular to a tangent line. Again, normal is meaning perpendicular, and perpendicular is the opposite sign and the reciprocal. Now that I have point, now that I have slope, y minus my y-coordinate equals m, x minus my x-coordinate. So I get y equals negative 1/3 x plus 4 is the equation of the normal line. Another application, find the x value or values where the tangent line to this function is parallel to this line. Okay, tangent line means to me take the derivatives. The derivative of 3e to the x is 3e to the x. That looks like minus 7x over 2, so minus 7/2 x would be minus 7/2. If they wanted a horizontal tangent is where the derivative is 0. But they don't want a horizontal tangent. They don't know where this tangent line is parallel to this line. So let's find the slope of that line. Solve it for y. Subtract the 2x over, divide everything by 4, and you get the slope here is negative 1/2. And parallel is going to be the same slope, so it stays negative 1/2. I want to know where the tangent line is this slope. So if you see parallel or even perpendicular, not normal, parallel or perpendicular, you're probably taking the derivative and setting it equal to that parallel or perpendicular slope right here. So 3e to the x minus 7/2 equals negative 1/2. Let's solve this on the next page. 3e to the x minus 7/2 equals negative 1/2. Here we go. Add the 7/2 over. So negative 1/2 plus 7/2, 6/2, which is 3. Divide both sides by 3. E to the x equals 1. Take the natural log of both sides, and the natural log of 1 is 0. So this is a location, x equals 0, where the tangent line to this function is parallel to that line. and there's a few applications dealing with exponentials and their derivatives.